Welcome to Mr. Ace Math. This lesson is on converting fractions to decimals. But before you can successfully complete this lesson, you need to make sure that you know how to use long division. So make sure you know that, and let's get started. Here's a step-by-step process. So step 1. We're going to divide the numerator by the denominator. Step 2. We're going to place a decimal point in the dividend and the quotient. And step 3, we're going to annex zeros as needed. Now, there's a lot of math vocabulary here, which might make it a little bit confusing. So I'll go over each of these words as we go over example 1, which is 5/8. But before we even go into the math vocabulary, let's set up our long division notation. Now remember, step 1 is to divide the numerator by the denominator. The 5 is our numerator. And because the numerator is getting divided, it's going to go inside the long division notation. The 8 is our denominator. And that's going to be doing the dividing, which means it goes outside the long division notation. So now that we're done with step 1, we can go to step 2, which is to place a decimal point in the dividend and the quotient. The dividend is the number inside the long division notation. So I'll place a decimal point right here behind the 5. So that is the decimal point in the dividend, and the quotient is right above the long division notation. So we'll put it right above that other decimal point here. Now that placement is incredibly important. So make sure when you write the decimal point in the quotient, it's right above the decimal point in the dividend. And now, step 3. We're going to annex zeros as needed. So when you're told to annex zeros, that just means that you're writing zeros to the right of the decimal point as placeholders. So I'll put a 0 here. I like to put at least 2 zeros. I'll put a 0 here and a 0 here. And then we can start our division column by column. How many times can 8 go into 5? Well, that's 0. So right above the 5, we'll put a 0. So we know 8 can't go into 5, so let's try to put it into 50, these two digits together. And how many times can 8 go into 50? Well, that's 6 times. So I'll put a 6 right above this 0. And then we'll multiply. 6 times 8 is 48. So we'll write that here, right under 50. And then we'll subtract that. We can't do 0 minus 8. We'll make this a 10 and make this 5 a 4. 10 minus 8 is 2. And 4 minus 4 is 0. Then after we're done with our subtraction, we'll bring this 0 down. Notice how I'm leaving a lot of space between my numbers so that I don't make a mess and make a mistake that way. And now we'll just repeat the process. How many times can 8 go into 20? Well, that's 2. So we'll put a 2 right above this 0. Then we'll multiply 2 times 8, which is 16. And we'll put that right under 20. And then we'll subtract. We can't do 0 minus 6, so we'll borrow there. This will become 10, this 2 becomes a 1, and then we'll subtract. 10 minus 6 is 4. And 1 minus 1 is 0. Since we have something left over, this means that we're going to have to bring down a 0. But before we can do that, we have to annex the 0, which means put it here as a placeholder. So let's write 0 here. And then we'll bring that 0 down next to the 4 to give us 40. And then we'll repeat the process. How many times can 8 go into 40? Well, that's 5 times. So we'll put a 5 right above this 0. 5 times 8 is 40. We'll write that right under this 40 here. We'll subtract, and that will leave us with 0. Since we have a remainder of 0, that's our sign that we're done. And this means that 5 over 8 is equivalent to 0.625, properly read as 625 thousandths. So here's example 2, 7 over 9. Before we even begin, let's make sure that we set up our long division notation. And remember, the number on top, this 7, is our numerator, which means it's going to go inside the long division notation. This 9 is our denominator, and that's going to be doing the dividing, which means it's going to go outside of the long division notation. Then we're going to place the decimal point in the dividend and the quotient. Remember, the dividend is the number inside of the long division notation. So we'll place a decimal point right here. And we also have to bring it right up into the quotient, directly above that first decimal point. So we'll place it right here. And then we're going to annex zeros as needed. Annexing zeros just means that we're going to put zeros to the right of the decimal point as placeholders. And make sure you leave a little bit of space in between so that your work is nice and neat. So we'll put a 0 here. And I like to start with at least 2 zeros, so I'll put another 0 right here. And now let's start dividing, column by column. How many times can 9 go into 7? That's 0 times. So we'll put a 0 above that 7. Next, we're going to try and go into not 7, but 70. And how many times can that happen? Well, that will be 7 times. So we'll put a 7 right above this 0. And 7 times 9 is 63. So I'll put a 63 right under the 70. We'll subtract that. We can't do 0 minus 3, so we'll borrow from 7. We'll make it a 6. And this 0 will become a 10. 10 minus 3 is 7. And 6 minus 6 is 0. After our subtraction, we'll bring down the next digit. So let's bring this 0 down right next to the 7, making 70. Now that sounds really familiar. In fact, that's exactly what we started dividing. We started by dividing a 70 right here. If that happens again and again, then that's our sign that we're going to end up with a repeating decimal. So let's repeat the process. How many times can 9 go into 70? Again, that's 7. And 7 times 9, again, is 63. And again, we're subtracting 63. And again, we're going to have to borrow from this 7, make it a 6, and make this 0 a 10. 10 minus 3 is 7, and 6 minus 6 is 0. This means we're going to have to annex another 0 here, and then bring that down, because we have a remainder here, and when we bring the 0 down, we end up with 70 again. So we have a pattern repeating of numbers that we're going to end up dividing. And when we try to divide 70 by 9, we're going to get 7 again. And that's going to happen again and again and again, because we end up dividing 70 by 9 every single time. That was a 70, we ended up with a 70 here, and if we did this again, we'd end up with another 70. So this is going to give us a repeating decimal of 0.7777, which we would also write as 0.7 repeating. So we would say the fraction 7 over 9 is equivalent to the decimal 0.7 repeating. So here's your pause and practice. Pause the video, and once you have all of your answers, hit play to reveal the answers. Ready, go. So here are the answers. So number 1 is 0.2, also read as 2/10. Number 2 is 0.27 repeating, properly read as 27 hundredths repeating. Number 3 is 0.7, properly read as 7/10. Number 4 is 0.75, properly read as 75 hundredths. Number 5 is 0.6 repeating, properly read as 6/10 repeating. Number 6 is 0.125, properly read as 125 thousandths. Number 7 is 0.5 repeating, properly read as 5/10 repeating. And number 8, 0.83 with a repeating 3, properly read as 83 hundredths with a repeating 3. So, let's reflect on what we've learned today. How many steps are there when converting fractions to decimals? There are 3 steps. Step 1 is to divide the numerator by the denominator. Step 2, place the decimal point in the dividend and the quotient. Remember, those decimal points need to be lined up. And step 3 is to annex zeros as needed. Remember, annexing zeros just means that you're putting zeros to the right of the decimal point as placeholders.
Don't forget to like, share, and subscribe. Questions? Comments? Leave them down below.
And thanks for using Mr. Ace Math. Don't just pass math, ace it.